All right, algebra, section 6.6, systems of inequalities. Let's get rocking and rolling here. So we're going to graph and understand the solution for a system of inequalities. So we've dealt with systems of equations all through the chapter, and we know how to solve them. And then we did word problems with them. Now we're going to talk about inequalities, the system of inequalities. So we're going to graph and understand those. So first thing is, what is this system of inequalities? Just like equalities, just like equations, it's two or more inequalities. You need two or more variables, and then you need like a less than or greater than, less than or equal to, or greater than or equal to symbols in there instead. Solving a system of inequalities. So first, we got all ordered pairs that satisfy both inequalities. So what the deal is here is your answers are only going to be the things that satisfy both inequalities. In other words, you'd have to get a true answer or a true statement for both inequalities for it to be a solution. And once we get the graphing, you'll understand that a little bit better. Easiest graphing, that's the easiest way to solve. And then, as we know, we're going to put it into y equals mx plus b form. Slope-intercept form is the way to go when you're graphing, and we know that's the easiest. So what we do is we graph both inequalities on the same coordinate plane. And then, of course, remember, you're going to either use a solid line or a dashed line based on if it's greater than or less than, or greater than equal to or less than or equal to. So remember your solid and dashed lines with inequalities. And then remember our shading. Shade each inequality. We're going to use a test point. Remember, 0, 0 is the best test point to use, as long as it's not on that line. If it is, then use something else. And then that solution is the entire double shaded part of the graph. So if there's a situation where we have both graphs shaded, then that'll be your solution. Okay? So let's do some examples. So the first one, that's a good one to do because they're already in slope-intercept form. And so there's not much work that has to be done because we already have it kind of in y equals mx plus b form. Okay, so with that already being there, then we're all set to graph. So the first thing I'm going to do is I'm going to look for my first equation. I'm just going to draw a line between them just to show that we're separating them. And what's my b value of the first one? Well, it's 1. That's my y-intercept. And then my slope is a -1, or -1 over 1 if you'd like. And then what type of line is it going to be? Since it's just less than or greater than, in this case it's a less than symbol, it's going to be a dashed line. Dashed line. Okay, so let's get our points on there. We have b value, y-intercept of 1. Okay, and then our slope says to go down 1 over 1. So down 1 over 1 puts me here, down 1 over 1, down 1 over 1. Okay, and then it's going to be a dashed line. So when I draw this line, I'm going to make it a dashed line through here. Whoa, didn't want to do that. Let's get that back. How'd that happen? There we go. How did that happen? Anyways, we're going to do that. So here's our graph, and I made it a dashed line. Nah, I don't like that. So let's just draw it in red the best we can. Okay, there we go. And now I'm going to use my test point, okay, to get my shading done here. And my test point, I can use 0, 0 because 0, 0, as you see, is not on that line. 0, 0 is right here. So I could use 0, 0 as my test point. So when I do that, I'm going to plug just a 0 here and a 0 here for my x and y. And I end up with a situation where I'm going to have 0 is less than 1. Is that true? Well, yes, it is true. So because it's true, I shade the side where 0, 0 is. So I would shade all of this. And I'm going to do it in red because I'm using the red line. So I'd shade this side here. Okay? Now, I got to do the second graph. Okay, so we're keeping these separate. I'm going to do this one in blue. So in this case, I've got a b value of 3, and my slope is a +2, or +2 over 1. And what type of line is this going to be? Well, because it's an or equal to, it's going to be a solid line. So we're going to graph this one. We got a b value of 3. 1, 2, 3. There you go. And our slope says 2 over 1. So we're going to go 1, 2, up 2 over 1, up 2 over 1, up 2 over 1. I'm going to get another point down here as well. But basically, you kind of ignore the line that you already have when you're doing the second line. Ignore that one. And then we're going to draw a solid line through here. So just kind of ignore that first line. Okay. Now it comes to the test point. I can use 0, 0 again because 0, 0 is not on that line. So I can use 0, 0 as my test point. And when I do that, I've got 0 less than or equal to 2 times 0 plus 3. So essentially I have 0 less than or equal to 3. And is that true? Well, that happens to be true as well. So that means I shade the side where 0, 0 is. So I shade this entire side of that line. So remember, I'm dealing with the blue line, so I'm going to shade all of that. And so now we got to look at, for our solution, is going to be all the points in where there's double shading. So I'm going to do that in black here. You can see where there's green and red shading here. All that is double shaded. So these would be your points. That would be your solution. So what it means is basically any point in this double shaded area would be a solution for this system of inequalities. So for example, the point -3 or 2, -3. 1, 2, down 3, right in here. That point would be a solution because it lands inside there. So we could find any point in that section would be a solution. So it's the double shaded area is what we're looking at. Okay? So when we do that, make sure that you shade that maybe a little darker or use a different color if you're using color or a different pattern, but make sure we can recognize the double shaded area. Okay? Let's do another example. And let's do this one because these ones are not in slope-intercept form. So we have to get them there. So it's not hard to do. It's not hard to do. Again, I'm just going to draw a line between them and keep them separate. Okay? And we'll do this one over here. So we've got x minus y is less than -1. Okay? So to get this into slope-intercept form, we know I'm going to have to subtract an x from both sides here. And so now I'm going to have a -y less than -x minus 1. Now I can't have the -y, so I've got to divide by a -1. And now just I got to divide everything by -1. And just keep in mind that, remember back from Inequalities, that chapter, when you divide or multiply by a negative number, we have to flip the inequality sign. So in this case here, I'm going to have a y. I've got to flip that sign now because I'm dividing by a negative. And I've got a positive x and then a positive 1 here. So now when I graph this, I've got a b value of 1. And my slope is also 1. And this is going to be a dashed line because it's just greater than in this case. So I got a plus 1 here. I'm going up 1 over 1, up 1 over 1. And it's going to be a dashed line through here. So I'm just going to try to draw my dashes. Okay, I extend those, give me my arrows. And now I'm going to use the test point. I can use 0, 0 because it's, of course, not in that point. So when I plug in 0, 0 here, 0 for y, I can plug it into any of these, the original equation, or I can plug it into this last one. So I'm plugging in the last one here. I got 0 is greater than 0 plus 1. So 0 is greater than 1. Well, that's false. We know that's false. So when I shade, 0, 0 is over here. Remember, I'm shading on the opposite side of the line. I'll be shading over there. Whoops. I can't shade on the line because it's dotted. So all this stuff will be shaded. Okay. And now the second line. Let's work on that one. So here we've got x minus y is greater than 3. So I know on this one, I'm going to have to Again, subtract an x. And that gives me a negative y greater than negative x plus 3. And again, I have to divide by that negative 1 because I've got to get rid of that negative sign there. And so now what happens to that inequality? Of course, it changes. And now I've got an x, and I've got a negative 3. So my b value in this case is going to be a minus 3. And my slope is also a 1, positive 1. Or you could say 1 over 1 if you want. To help it rise and run. What kind of line is it going to be? It's going to be a dashed line because of there's no or equal to there. So I start with that negative 3, 1, 2, 3. On my y-intercept, that's my b value. And my slope is up 1 over 1, up 1 over 1. And you may have noticed that these are parallel lines because they have the same slope. So you can see they're never going to cross. Okay, and so now I'm going to use that test point. I can use 0, 0 because 0, 0 is not on the line, so I can use 0, 0 as my test point. So when I do that, I'm going to plug it in down here. 0 is less than 0 minus 3. 0 is less than minus 3. Is that true? No, that is false. That's false. 0 is actually greater than minus 3. So I'm going to shade, here's 0, 0. I'm going to shade the opposite side of that. Because here's 0, 0. I'm going to shade the opposite side because it was a false answer. So I shade over here. So this is an interesting case because remember our rule said that our solution is anywhere where there's double shading, anywhere there's shading for both. It has to satisfy both equations. Well, in this case, that does not happen because there's only shading on opposite sides of the line. There's no area on this graph where there is double shading. So in this case, we would have an answer of no solution because our only solutions are where both equations are true. So you'd need double shading to have an answer there. So it'd be no solution. Okay. There's some more practice problems here, 3 and 4. They're both already in slope-intercept form, so if you want to take a stab at those, go for it. Other than that, we'll get to the lesson summary here. When graphing a system of inequalities, where do you find the solution? So we should be able to know that. And over here, we've got a grid, so you know what we're going to have to do over here. Solve this system of inequalities by graphing. You've got your inequalities there. Graph them, find a test point, shade them, and see what happens. Other than that, bring your questions, and let's get ready to go on this final section in Chapter 6.